Metal has been a constant source of invention and discovery from the beginning of human civilization to the present, forming everything from tools and weapons to enormous buildings and spacecraft. Let's explore the intriguing process of making metal, following its development from unprocessed ores to the lustrous alloys that shape our world. The history of metal begins millennia ago, deep under the surface of the planet, where geological forces have concentrated rich deposits of metallic ores. Mining, the first stage of metal production, involves the extraction of these ores from the earth. This process has evolved significantly over time, transitioning from simple manual techniques to highly sophisticated mechanized operations. Early miners used basic tools such as pickaxes, hammers, and chisels to break rock and extract valuable minerals. These methods, while effective, were labor-intensive and limited in scope. In contrast, modern mining employs advanced technologies and machinery to increase efficiency and reach deeper ore deposits. Techniques such as open-pit mining, where large swaths of earth are removed to access ore, and underground mining, which involves creating tunnels and shafts to reach buried deposits, are commonly used. Advanced drilling machines, explosives, and automated equipment have replaced manual labor, allowing for the extraction of vast quantities of ore with precision and reduced human risk. The choice of mining method depends on factors such as the type of ore, its location, and the surrounding geology. Once the ores are extracted through mining, they undergo a series of extraction procedures to isolate the target metal from the surrounding mineral matrix and rock. The initial step in this process involves crushing and grinding the ore to reduce it to smaller, more manageable particles. This increases the surface area of the ore, facilitating more effective extraction of the metal. Crushing is typically performed using jaw crushers and cone crushers, which break the ore into smaller pieces. Grinding further pulverizes these pieces into fine particles using mills equipped with steel balls or rods. The metal is then separated from contaminants using various methods tailored to the specific type of ore and desired purity of the metal. Flotation is a common technique for sulfide ores, where the ground ore is mixed with water and chemicals to create a frothy mixture. Air bubbles are introduced, causing the metal-containing particles to attach to the bubbles and float to the surface, where they are skimmed off for further processing. Smelting involves heating the ore to high temperatures in a furnace, typically with a reducing agent like carbon. This causes the metal to melt and separate from impurities, forming a molten metal pool that can be poured into molds. Leaching, another method, uses chemical solutions to dissolve the metal from the ore. This is particularly effective for low-grade ores or ores that are not amenable to smelting. The dissolved metal is then recovered from the solution through processes such as precipitation or solvent extraction. Each of these extraction methods plays a crucial role in producing high-purity metals ready for further refinement and use in various applications. Raw ores rarely yield pure metals directly. Instead, they usually contain a variety of impurities that need to be removed by purification and refining. This critical stage in metal production involves a range of chemical and physical methods designed to convert low-purity ores into high-purity metals, showcasing the true power of metallurgy. The goal is to achieve a metal that meets specific purity standards required for various industrial applications. This process often starts with ore concentration techniques that increase the metal content by removing unwanted minerals. Following concentration, the ore undergoes further treatment to eliminate impurities. A popular technique called smelting entails raising the temperature of the ore to a high point while a reducing chemical, such as carbon, is present. This process causes the metal to separate from its ore as it melts into pools, which can then be poured into molds. The intense heat and reducing agent helps to remove impurities and produce a purer form of the metal. Smelting is particularly effective for extracting metals like iron, copper, and lead from their ores. Another important method is electrolysis, which is used to produce metals like aluminum, zinc, and high-purity copper. This technique involves dissolving metal ions in a solution and using electric currents to deposit them onto electrodes, forming pure metal cathodes. Electrolysis is highly effective for achieving high purity levels, as it allows for the precise removal of impurities at the molecular level. By applying a direct current, metal ions are reduced at the cathode, where they accumulate as a pure metallic layer. Both smelting and electrolysis are fundamental to producing high-quality metals essential for modern industrial applications. Although pure metals have special qualities of their own, their usefulness frequently rests on their capacity to create alloys by carefully combining various basic components. The process of alloying metals with complementing elements to give them increased strength, durability, and versatility is known as alloying. For example, ancient artisans found that bronze was created when copper and tin were combined. This resulted in a metal that was considerably better than either of the individual elements. In order to customize an alloy's qualities for a given use, such as structural steel for buildings or stainless steel for surgical tools, modern metallurgists combine iron with exact amounts of carbon and other elements. After metals have been purified and alloyed, they are shaped into the various items that make up our contemporary world. This stage of metal production involves methods tailored to the specifics of each material and its intended use, whether it's the girders of bridges or the parts of microelectronics. The versatility and durability of metals make them ideal for countless applications, requiring a range of shaping techniques to meet diverse industrial and consumer needs. Traditional and modern metal fabrication techniques offer a broad spectrum of possibilities. Forging, one of the oldest methods, involves forming metal billets into sturdy components using heat and pressure. This process enhances the metal's strength and structural integrity, making it suitable for high-stress applications. Casting, another fundamental technique, involves pouring molten metal into molds to create intricate designs. This method is ideal for producing complex shapes and large quantities of identical parts. Cutting-edge technologies, such as additive manufacturing, also known as 3D printing, have revolutionized metal fabrication. This technique builds up metal components layer by layer from a digital model, allowing for the creation of complex shapes with previously unheard-of efficiency and precision. Additive manufacturing is particularly advantageous for producing custom or small batch parts, reducing material waste and enabling rapid prototyping. As technology advances, these innovative methods continue to expand the possibilities for metal fabrication, pushing the boundaries of design and functionality. Technological advancements in metal extraction and processing are transforming the sector by providing effective and sustainable substitutes for conventional approaches. The two well-known cutting-edge technologies driving this trend are plasma arc recycling and bioleaching. By using microorganisms, bioleaching is able to recover metals from ores. By oxidizing metal sulfides, these microorganisms liberate the necessary metals in a commercially and environmentally sustainable manner. Bioleaching is a viable method for sustainable metal extraction, since it reduces the need for harsh chemicals and energy-intensive processes by using naturally occurring organisms. Another innovative method of treating metal is plasma arc recycling. This technique efficiently separates and purifies metals by dissolving them into their individual components using high-temperature plasma. In contrast to traditional techniques, plasma arc recycling can process a variety of metal sources, such as complex alloys and electronic trash, with low emissions and waste reduction. It is essential to transition to more environmentally friendly methods of processing metals because of its adaptability and advantages. The metal industry may change as a result of these technologies' continued development, paving the way for a more ecologically friendly and sustainable future. Metal's transformation from raw ore to refined alloy is a prime example of human inventiveness and perseverance. Metal has a long history of innovation, from the depths of Earth to the furthest regions of space, propelling the developments that have shaped our world. The future of metal production promises to meet the needs of contemporary society, while protecting our planet for future generations through innovative technology and sustainable practices.